We gather here today for the inauguration of second international meeting on energy storage devices 2023 and Industry Academia Conclave. IMESD 2023 marked the commencement of a dynamic gathering of diverse minds from across the globe. Esteemed dignitaries, research scholars, and industry leaders have come together to discuss recent trends and future directions of energy storage devices. With this brief opening remark of the conference, I would like to welcome all the distinguished guests, delegates, and participants to the conference. Now, I would like to invite Padma Bhushan, Dr. V.K. Saraswat, Professor P.V.R. Chaudhary, Director, IIT Roorkee, Chairperson and Convener of Conference to come on stage. Please. Now I request PhD students to offer bouquet to our chief guest. Now I request all to rise for Kulgir.
Rasensan, Jayati Jayati Rasensan, Indri Shingo, Seya Prinande, Jayati Jayati Rasensan, Jayati Jayati Rasensan, Shiksha. आदर्शों में उन्नत जीवन शिल्पी मूलचनारत शिक्षा आदर्शों में उन्नत जीवन शिल्पी श्रमं विना न किमपि साध्यं यन्त्रकलाकौशलभियान् जयति जयति विद्या संस्थान जयति जयति विद्या संस्थान जन जीवन प्रसाद उठाकर सेतु बांध भूखंड जुड़ाकर जन जीवन प्रसाद उठाकर सेतु बांध भूखंड जुड़ाकर अंतरिक्ष में यान उड़ाकर जयति जयति विद्या संस्थान जयति जयति विद्या संस्थान सज्जन हित जीवन नित अर्पित थया स्वर्ग शोभा निर्मित सज्जन हित जीवन नित अर्पित थया स्वर्ग शोभा निर्मित विज्ञान ऊपर लहरा स्वर्ण विमान जयति जयति विद्या संस्थान जयति जयति विद्या संस्थान प्रेरणा से दीपित मन नव स्वप्नों से हर्षित लोचन प्रेरणा से दीपित मन नव स्वप्नों से हर्षित लोचन नए सत्य की पुर में राष्ट्र जीवन कल्याण जयति जयति विद्या संस्थान जयति जयति विद्या संस्थान दिव्यशृंगों से अभिनंदित गंगा जल करते कल्याण जयति जयति विद्या संस्थान जयति जयति विद्या संस्थान जयति जयति विद्या संस्थान जयति जयति विद्या संस्थान
I request all the delegates for the lamp lighting ceremony.
शुभं कुरुत्वं कल्याणम् आरोग्यं धनसम्पदः शुभं कुरुत्वं कल्याणम् आरोग्यं धनसम्पदः शत्रुबुद्धिविनाशाय दीपज्योतिर्नमोऽस्तुते दीपज्योतिर्नमोऽस्तुते दीपज्योतिर्परब्रह्म दीपज्योतिर्जनार्दनः दीपज्योतिर्परब्रह्म दीपज्योतिर्जनार्दनः दीपो हरते सन्ध्यादीपनमोऽस्तुते ओ दीपब्रह्मरूपस्थं ज्योतिषां प्रभुराज्ञः ओ दीपब्रह्मरूपस्थं ज्योतिषां प्रभुराज्ञः युक्ते पुत्रांश पतिं स्वच्छामि मे सदा रवेरस्तं समारभ्य यावत् सूर्योदयो भवेत् रवेरस्तं समारभ्य यावत् सूर्योदयो भवेत् यस्य दृष्टिः गृहे दीपः तस्य नास्ति तदेकता शुभं कुरुत्वं कल्याणम्
Now I invite Professor Yogesh Sharma, convener of the conference, to give a brief overview of the conference.
Hello and warm welcome to inaugural ceremony of second international meeting on energy storage devices and Defense Industry Academia exhibition we are going to have. First of all, I'm highly grateful to all of you for your overwhelming response and support to this conference and conclave. We shall have over 600 participants from all over India and abroad in the next 3-4 days. All thanks to you. If you remember, we last met in 2018 in the first edition of IMESD. Your enthusiastic response that time has always motivated us to organize the second edition. And however, COVID gave us a tough time to all of us to meet physically, but now that bad times has gone and we able to have you here with our green campus. I need not to say anything. We all are here to exchange our ideas. Just to give some brief about what we are going to have. As I told you, we will be having many panel discussions tomorrow, and we were DRDO is kind enough to provide us different models, which has been they are utilizing in different strategic application to showcase at IIT Roorkee to the people so that they will also get to know what actually our nation has done. We will be having exhibition, as I told you, 10 different laboratories from DRDO are participating into it. We also have many people from ARCI and different IITs, DST. The C3 division is also taking part into this exhibition. So, and Hyderabad Battery Limited, Urja Energy, Indie Energy, and many more will be showcasing their products and prototypes. So with all, I welcome you again because it's delayed. So I don't want to take much time. Thank you very much that you came, and I hope you will be having a wonderful time and technical discussion mainly in the next 3 to 4 days. Thank you very much.
Thank you, sir. Now I would like to call our chairperson, Professor Vipul Chand Rastogi, to say a few words for the conference.
Dr. Saraswat, Professor Chaudhary, Professor Pant, Professor Yogesh Sharma, all the distinguished guests of the dais, dear participants, students, ladies and gentlemen. It gives me great pleasure to welcome all of you to this second edition of IMESD. And this conference aspires to unite distinguished scientists, esteemed academicians, dedicated research scholars, accomplished engineers, and visionary industrial technocrats on a single platform, fostering comprehensive discussion across diverse domains of energy storage. I'm confident that this gathering will serve as a prominent stage to showcase not only high quality research and development, but also to cultivate interdisciplinary thinking, paving the way for innovative breakthroughs in energy storage devices that contribute to sustainable development. Department of Physics was established in 1960, and since its inception, the department has grown quite a lot and has been renowned for excellence in both teaching and research. We offer diverse academic programs. We have a 5-year integrated MSc Physics or BSMS Physics, it has been converted into, then 2-year MSc Physics, We have three MTech programs. One is MTech in solid state electronic materials. One is in MTech photonics. Then we have recently started with, in collaboration with Taiwan universities and with the ECE department, an MTech program in semiconductor technology. And we also have our BTech engineering physics program, 4-year program, which is doing very well. So this shows that the department caters to a comprehensive spectrum of educational needs. In addition to disseminating knowledge within the classroom, our faculty members actively engage themselves in cutting-edge research across critical domains. This research is made possible through, of course, valuable support from several industries, several sponsors, which include CSIR, DST, DAE, ISRO, DRDO, and industry, of course. There are a large number of sponsored projects going on in the department, which serve as a testament to unwavering commitment of the department in pushing boundaries of scientific knowledge and fostering advancements in their respective fields. Notably, our department boasts a state-of-art laboratory dedicated to the realms of energy conversion and storage. And it is my firm belief that the Department of Physics will play a pivotal role in pioneering research and development initiatives focused on energy conversion and storage. With a special emphasis on cutting-edge technologies like perovskite, solar cells, fuel cells, and rechargeable batteries. Through these endeavors, we aim to contribute significantly to the sustainable development of our nation as a whole. So with these words, I again welcome all of you to IMESD 2023 and wish all of you a very happy, fruitful, and pleasant stay at IIT Roorkee. Thank you.
Thank you, sir. Now I would like to request Professor K.K. Pant, Director IIT Roorkee, to address the dignitaries from the dais.
Very good afternoon to all of you. Our chief guest of the day, Padma Shri Dr. V.K. Saraswat, member NITI Aayog. The distinguished guest from National University of Singapore, Professor Chaudhary. The convener of this program, Professor Yogesh Sharma, and head of the department, Professor Vipul Rastogi. All the distinguished guests who have come from all over India as well as from abroad. All the faculty colleagues of IIT Roorkee and all the research scholars, guests. A very good afternoon to all of you. This IIT Roorkee, which is also known as Devbhoomi Uttarakhand, has its own heritage values, and we always believe in sustainable development technology. Having said that, when this kind of conference, international conference or international meeting on energy storage devices, as well as the industry academia interaction meeting, where the defense showcase is also there, I think this is the need of the hour, that how the indigenous technologies can be developed within the country by using the research and development expertise knowledge in different areas of science and engineering. When we talk about the material, when we talk about the devices for energy, when we talk about sustainable energy, then there are a lot of challenges with every academia and the research institutes. And this is a global problem. We always talk in terms of one earth, one family, one solution. With that concept, when you talk about how these kind of new materials or novel materials can be designed or divided with high energy and highly efficient, that's challenge. Similarly, when you talk about the battery or a fuel cell,
always the efficiency improvement is a big challenge. And when we talk about sustainability, then we talk about the circular economy concept also. So how to get rid of this, all these kind of issues with a kind of right overall output to input ratio. And then the green hydrogen is again coming in picture. So whether green hydrogen or clean hydrogen and how this hydrogen can be transported or stored and then dispensed effectively for the vehicular application for mobility purpose. That's again a new challenge for the everyone. I am sure that these 3 days of the conference will bring some new domains, will get some new ideas on not only the material, because material development for battery is still a challenge. The economy of the process is still a challenge, and the efficiency of the process is still a challenge. The entropy is always a challenge, and all these battery materials which have been designed or devised, they are low in entropy. So there is a lot of heat loss. So how can we minimize the heat loss, whether it is a fuel cell application or it is a battery application? If you are able to minimize those losses, then of course the efficiency will increase. So just for an example, the fuel cell which are running at 45% of efficiency, even if you are able to, there is a 25% is the loss. If you are able to recover that loss and reuse it in the process, then efficiency can be brought down to a level of 60 or 70% or 75 also. So that is, I think, the challenge where all the R&D institutes have to work together. So it becomes a not only just like a physics, chemistry, but also engineering and multidisciplinary approach of science and engineering would be very important. And we always talk in terms of our educational or curriculum system also that the science, engineering, mathematics, and finally, when you talk about the market readiness level of all these technologies from TRL 3, 4, 5 to 9, and finally the societal relevance as well as the market. So community relevance is also very important. So we should say CRL as well as the market readiness level, and then only the technology can be transferred for the commercial success. I think we need to address all the challenges, how to get a high quality, highly efficient material and highly efficient energy device, which can be in either form, a fuel cell or the hydrogen, or maybe other like wind energy, geothermal energy, whatever the renewable source of energy we are able to utilize. I think all these require the highly efficient processes, and for that lot of R&D is to be done. So I congratulate the entire team of this conference or meeting for sparing the time, and I just thank you all the guests who have come all over the way from the India as well as from the abroad, and I hope that you all will have a comfortable stay during your 3 to 4 days here in the campus. The campus has its all, right? When you talk about flora or fauna, please enjoy that also. The 176-year-old institute which has its own heritage value, and we believe in, as I said, sustainability. We believe in that the hospitality. So please feel free to interact with us if you face any difficulty, and I wish you a very comfortable stay at the campus. Namaskar. Jai Hind. Thank you.
Thank you, sir. It's a privilege for all of us to have our guest of honor, Professor B.V.R. Chaudhary, Senior Executive Director and President Emeritus, Materials Research Society of Singapore. Professor B.V.R. Chaudhary is director at Nanyang Technological University, Singapore. He has a long research period of nearly 50 years, and he has served in Kanpur, India, Nanyang University, Japan, University of Stuttgart, and many more. Professor Chaudhary was conferred the title of Officer in the Order of Academic Palms by the French government and the Business Event Ambassador by the Government of Singapore. His research interests are development of electrode and electrolyte materials for energy storage applications, including lithium-ion batteries. He has published nearly 300 papers. Increased and have citations of more than 19,000 with an H index of 71. He is the editorial board member of many international journals. His administrative responsibilities include fostering research collaboration between NTU Singapore and the Indian universities and institutes of higher learning through research internships, student and faculty exchanges, joint symposia, and joint PhD programs. as the current chairman of the International Conference on Materials for Advanced Technologies. Professor Chaudhary is responsible for promoting the knowledge capabilities of local researchers internationally and establishing extensive collaborations with the global scientific communities. I would like to request Professor B.V.R. Chaudhary to come on dais and say a few words for the conference.
Good afternoon, everyone. I hope you can hear me. Thanks to energy storage devices, without which you can imagine you can't hear such a senior man sitting that far away. In fact, in this context, first of all, we have to thank all those who have contributed to the development of energy storage devices and who are currently working and who are planning to work. And I must say one thing, that having started doing research in this specific area several decades ago, I can still see there's a great scope, and this is something ongoing, and you can feel confident that at every stage, whatever the stage you are, whether you are a student or a middle class or middle level professor or senior professor, there is still a lot to contribute. Thanks to organizers for giving me this opportunity, for sharing a bit of my thoughts here. And before I do that, of course, I have to thank Dr. Saraswat, who I know for many years, for taking time for joining today. And that itself is a great recognition for the importance of this particular conference and the field. Thank you, Dr. Saraswat. And of course, the leadership of IIT Roorkee. Without their support, this conference or this meeting would have not taken place. Now, as was mentioned, I have little experience, I would say, of organizing some of these conferences before, similar ones before, but at a different scale. But whatever the scale may be, the problems remain same. And with every conference, new problems do keep coming. I'm happy that Professor Yogesh Sharma and the physics department as a whole is taking lead and doing a wonderful job here. And congratulations for him and his entire team for making this is a kind of memorable activity. Then one point I possibly would like to put as an open idea. And India is a vast country, it is a subcontinent, and we have young talent. And this is what I have been trying for over almost nearly 2 decades, for bringing the Indian talent to overseas and overseas talent to Singapore, and from Singapore to India. So there is a lot of scope in this global world for connecting internationally. So in that sense, I would like to see if this could be made a little more international, in the sense I'm not limiting to the energy storage devices only. You can really make it as a huge national conference or international conference, and also rotate among different regions of the country so that everybody gets an opportunity to participate and contribute to the nation and also internationally. This is just a open idea which probably one can think and imagine how to take it forward. With these few words, once again, I would like to congratulate the organizers, particularly the head of the Department of Physics, Professor Rastagi, and of course, Professor Yogesh Sharma, and everyone who has contributed for this particular event, and wish them all the best, I would say. Thank you.
Thank you, sir. It's my pleasure to introduce our chief guest, Padma Bhushan Dr. V.K. Saraswat, member of Niti Aayog. Dr. Vijay Kumar Saraswat is a distinguished scientist with vast experience in defense research in both basic and applied science. He is retired secretary from DRDO and he has illustrious career credited with the indigenous development of missiles such as Prithvi, Dhanush and Agni 5. As the Homi Bhabha Chair Professor and Consultant to IOCL R&D, Dr. Saraswat involved a roadmap of the development of alternative energy systems such as clean coal technologies, high efficiency concentrated solar power plants, and bioenergy as hydrogen-based economy. As member Niti Aayog, Dr. Saraswat initiated the methanol economy program for transportation, energy generation, and production of chemicals and fertilizers. He is the recipient of many awards, including the Padma Shri in 1998 and Padma Bhushan in 2013. He has been conferred as honorary doctorate by more than 25 universities. With these words, I would like to invite Dr. V.K. Saraswat sir to deliver his talk.
Very good afternoon. Namaskar to all. Shri Professor Pant, Director IIT Roorkee, Dr. Chaudhary, a very distinguished professor and scientist from Singapore, Professor Rastogi and Professor Yogesh Sharma, and very, very distinguished scientists and technologists who have come from abroad, distinguished faculty members of IIT Roorkee, and my dear young students, and ladies and gentlemen. It's an honor and a privilege to come and inaugurate this particular seminar, workshop, whatever you call it, on energy storage devices. So I thought it will be appropriate for me to share with you what work we are trying to do in Niti Aayog under the instructions from the Prime Minister's office. Basically, their idea is to develop standards for chemistry agnostic devices for energy storage and technologies. And during that process, we have taken stock of what is the kind of demand of such devices is going to be there for meeting the different disciplines, particularly storage for mobility, storage for grid connectivity, storage for base load, and so on and so forth. So I'm going to give you some glimpses of what is the kind of picture that is emerging as far as the energy storage devices are concerned. If you look at the background of this information, I hope the slides are visible. For 50% non-fossil based installed capacity by 2030, the solar installed capacity may reach about 320 gigawatts. And this will attract huge requirements for storage. India has a vision of about what we call the EV30, that is 30% penetration by 2030 campaign.
Under the Clean Energy Ministerial Electric Vehicle Initiative, again, this sector would also need number of storage devices. Then comes the demand for devices for rooftop solar, solarization of the agriculture sector like pumps and so on, industry and MSME sector that has to be supported by the battery storage. There may be number of storage technologies available. As Professor Pant was telling, that there are many types of storage devices which are being developed, which have been developed, like the pumped hydro, battery electric storage systems, flywheel, and different chemistry of cells which are under development or have been developed. But the requirement is that we should be in a position to arrive at some common standards across all the storage technologies, so that when you do the selection, we should be in a position to come out with the right choices. Now, if you take what is the initiative that has been taken by the e-mobility sector, central policies have favored and encouraged EV stakeholders to materialize e-mobility in future. And for that, number of schemes have been initiated by Government of India. You are aware of the famous faster adoption and manufacturing of hybrid and electric vehicles called FAME, and that FAME 1 has become FAME 2, and now there is a preparation for coming up with FAME 3. Then comes the National Electric Mobility Mission, and corresponding to that, for manufacturing of the battery cells and lithium-ion batteries and others, there's a production-linked incentive scheme which has been promulgated by the government. Phased manufacturing program has also been promulgated. Public charging infrastructure is being set up today, and battery swapping policy also has been worked out for smaller batteries, and special e-mobility zones are there. And there's a national electric bus program which is also being promoted today. Because of this program, there has been significant improvement as far as the scenario of the batteries are concerned. About 133% growth occurred in the electric vehicle sales between 2015 and 2020. 25 plus states have notified or drafted state electric vehicle policies. More than 1,800 electric vehicle charging stations have been already installed. 7,59,182 electric vehicles have been registered till today, and 380 electric vehicles manufacturing operates in India. 1.32% of all vehicle sales in 21-22 were electric vehicles, and we have about 2,656.6 kilotons of carbon dioxide emissions that have been reduced by this approach. And all this because of the advanced chemistry cells beyond lithium ion for a sustainable e-mobility which is under development. The total picture, if you look at it, for the energy storage scenario in India, which has been evolved under the program on ISGF 2019, this data is about 3-4 years old, but it indicates that for grid storage, you need something like by 2027, 2032, something like 67 and 142. For telecom towers, about 150 gigawatt hours. For data centers, about 474, and so on. Total stationary requirement of the energy storage is in the region of 1,002 gigawatt hours. When it comes to electric vehicles, the two-wheelers, it is about 496 in 2032, and for the three-wheelers about 136, four-wheelers will be about 725. Again, total electric vehicle requirement would be in the region of 1,414. In other words, the total energy storage demand is going to be about 2,416 gigawatt hours by 2032, and you can see the growth from 529 to 1710 that is likely to take place over the years from now till 2032. The overall storage estimates, this was a part of the cabinet note which we prepared for the advanced chemistry cell and battery chemistry storage. There are two factors identified here in that. One is on the left is the annual demand in terms of gigawatt hours per year. On the right hand side, the scale giving you the market size in terms of $1 billion. So if you see all the distributions, the $1 billion, if you look at it, market size from 2022, which is about 1, is going to grow to about $6 billion. In terms of the demand, what is there in 2022 is something like 8 is going to become about 103 gigawatt hours per year. That is a conservative scenario. If you take an accelerated scenario, which is what the government of India is planning to do, then you will have about the number is going to be from 2 in 2022 will rise to about 15. That is the kind of $1 billion of market expansion. When you look at the net total annual demand in terms of gigawatt hour per hours from 22, which is 21, it is going to go to about 288 gigawatt hours. So this is the kind of growth as far as the energy storage devices and battery chemistry systems are concerned. Now, requirement for the power sector, if we look at that, which has been worked out based on whatever was the National Advanced Capacity Cell and Battery Storage Scheme which has been given, the pumped hydro stations is about 18.98 in 2030, and battery electric storage is about 41.65 to 46.3 gigawatts. That is the kind of number that is emerging. Now, we have different technologies, we have different applications and different parameters which control basically for the use of the electricity. So we have electrochemical storage systems, which includes different kinds of batteries like lead acid, lithium ion, flow batteries, sodium metal air batteries, and so on. And the important parameters are safety and the performance. If you look at this table, what is given here, like the mechanical systems are pumped hydro storage systems, the compressed air storage system, and the flywheel energy storage systems. Whereas the electrochemical systems, in which most of you are very actively working today, are lead acid batteries of different kinds, starting from single polar to bipolar lead acids. Then, of course, the lithium ion batteries of different chemistries like LCO, LMO, LFP, and so on, NMC, LTO, and the NCA. The flow batteries, which are zinc bromide and vanadium redox batteries, and under development sodium ion battery, sodium sulfur batteries, sodium nickel chloride batteries, and in the metallic ones you have aluminum air, iron air, zinc air batteries. So these are major electrochemical chemistries which are under development or have been developed. When you look at the thermal area, you have sensible molten salt and the chilled water systems. Then the latent ice area, ice storage, phase change materials, that is what we have. And the thermochemical storage also is there. The electrical systems, all of you know, we have been using supercapacitors for many years now. And the capacities of supercapacitors, depending upon the improvement in the materials which are taking place, is increasing by day. Then superconducting magnetic energy storage system, what we call as SMEs, is also happening. Then Dr. Pant was talking about hydrogen. So you have power to power where we have fuel cell, and power to gas where the hydrogen storage systems come. Different kinds of hydrogen storage systems are there. You know, we have got hydrides, we have got the pressurized hydrogen storage systems, and then the liquefied hydrogen, and so on. So there are various methods by which you can store hydrogen. Each one of them have its own advantage and disadvantage. Now, the technology as far as these battery and storage systems are concerned have got different levels of maturity in what we have today. On this scale, what you are seeing is the research, development, demonstration, deployment, and mature technology. So many of the areas fall in the region of research, development, and demonstration, which includes synthetic natural gas, hydrogen, adiabatic compressed air facilities, then superconducting magnet, they fall in this, and supercapacitors, they have come to the demonstration. Even the flow batteries fall in the demonstration capacities. Whereas the deployment category, you have lithium ion batteries, molten salt batteries, flywheel, sodium sulfur, and sodium ion batteries, and so on. Then most matured, as we can see in the mechanical, is the compressed air energy storage system, and the pumped hydro storage system, which is available today, and many of the states have already started using this, almost about 1800 gigawatt kind of numbers, which is emerging as far as the pumped hydro storage is concerned. The capacity of different storage devices has been indicated in here. One is the storage capacity, another one is the discharge time. how much is the discharge time for each one of them. And if you see, starting from 1 kilowatt hour to as much as about 10 terawatt hours, you have flywheel, and then you have batteries, then you have compressed air storage, then the pumped air storage, then power to gas hydrogen and power to gas methane. This is the kind of ratio, and we can have anything as low as few hours to as high as about 1 hour, 1 year kind of a storage capacity in terms of time, discharge time. And you can have capacities anything between 10 kilowatt hours to as much as about 10 terawatt hours. So this is the kind of spread you are likely to get for different kind of storage technologies. Now, for each one of them, there is a different requirement as far as the performance is concerned. Higher energy capacity and cycle life are useful for all applications, but different sets of battery specifications are more viable depending on the exact use. And that's where the standards become very important. For example, EV, especially four-wheeler and buses, require high energy density but have little use for the cycle life, more than 4,000. Energy storage, particularly long duration, requires higher cycle life since energy density can be compensated for by sizing the bigger modules. And energy storage uses can also be differentiated in terms of RE integration and also requirement of ramping to meet the peak demand. So because depending upon how much is the peak demand, how much is the storage, and what kind of characteristics have to be provided for in that storage device. In this table, you can see with respect to the specific energy and cycle life. Cycle life is in terms of number of hours, number of cycles, and the energy specific device is watt hour per kg. You can see that if you have got more than 1,000 and 2,000, you can see specific energy in the region of 50. You have backup power, rooftop, solar, and so on and so forth. Whereas cycle life up to 10,000, you can go for frequency regulation, renewable energy. If as you go further, 125, 200, you can go in the region of 125 and 1,000 cycles, two-wheeler, three-wheeler batteries will come. In consumer electricity, it will be in the region of 2,000. And in the case of medical devices, it will be the region of 4,000 cycles. As you go further down, when the energy, specific energy requirement goes up, like consumer electronics, the four-wheelers and the EVs, high performance buses, consumer, you will go into the 2,000 cycle life. And further down, you see high performance EVs where you can have a 4,000 kind of a cycle life. Now, one of the major area which one has to consider is the requirement of various materials for the e-mobility transition. And particularly when you look at lithium, it becomes one of the major constraining parameters. Under EV30 at 30, India needs about 91 and 125 gigawatt hours of cumulative battery capacity to electrify its vehicle fleet considering lithium ion alone. Lithium, cobalt, and nickel, major components of the present battery technology, are expensive and availability is always a problem. So, and of course, there are issues with respect to extraction and the sustainability, which Dr. Pant was talking of, because then each of them has got impact as far as the emissions are concerned during the mining process, transportation process, storage process, and so on. That's why the future systems which are evolving are the solid state batteries, which is higher energy density, faster charging times, and improved safety compared to the current lithium-ion batteries. Sodium-based, advanced batteries will enable lower storage costs and environmental hazards. Another thing for sustainability is, and also meeting the requirement of materials, is the recycling of the lithium-ion batteries. This is another area which requires our attention. I find a couple of industries have already started working in this area, and India is going fairly ahead as far as the recycling of the lithium-ion batteries are concerned. In the e-mobility sector, other materials which are very, very critical are the rare earth materials, which are required for the magnets and many other electrodes and so on, and particularly materials like alnico, ferrites, boron, and cobalt-based magnets and things like that. So if you take the total picture of lithium, you will find that the world's lithium required to availability, the mine production in different countries is indicated here. The ratios are in the region of 7.2% for China, Argentina about 14%, and Australia 19%, and the maximum available in Chile about 58%. total global mine production is in the region of 85,000 tons. And global reserves are only 14,000 million tons. And the global resources are 62,000 million tons. This is as far as the total capacity of lithium is concerned. If you take lithium availability now and future, and then you link it with our lithium mining and industry capacity, is presently total mining, as I mentioned to you, about 85 tons of lithium carbonate per year against the reserves of 14 million tons. Implementing all electrified two-wheelers and three-wheelers in India by 2025 will require about 3,000 tons of lithium carbonate. Sorry, 30,000 tons of lithium carbonate, which is almost 35% of the global present lithium carbonate mining capacity. And of course, when the demand goes up, the prices are also going to go up. And the global projection of lithium-ion battery and requirement of lithium carbonate is 1,000 gigawatt hours by 2030 will require 0.74 million tons of lithium carbonate. 3,200 gigawatt hours by 2050 will require about 2.36 million tons of lithium carbonate. Considering enhanced global demand, 14 million tons, which is what is available, of the lithium reserves might be exhausted by 2040. That is the kind of concern we have if we put all our eggs as far as the lithium is concerned, lithium ion is concerned. And hence there's a requirement to look at beyond lithium ion. And that's why now we are looking at some of the comparative studies of various batteries like flow battery, which offers advantages in terms of very long cycle life, high power and voltage delivery. Drawbacks are low specific energy, requires spatial housing for thermal safety, and also high system costs. Applications are many, like long duration storage and so on. Sodium sulfur, very high cycle life, good specific energy, low input material cost, and cost competitive with traditional lithium batteries. Use environmentally benign materials. But problem is high temperatures required for operation raise safety concerns. And currently high system cost, but I think that will be overcome once you go to the large scale production. It can be useful for long duration storage, grid support applications. Sodium ion, which I was given a demonstration just now as I came in, wonderful work being done. Low material cost for sodium, more abundant and sustainably sourced. Allows easy and safe transport without any loss of performance, and low tendency for dendrite growth on charging, which is one of the major problems as far as lithium is concerned. So currently in the initial commercialization phase has not achieved scale and relatively lower energy density and cycle life performance. Grid storage could be one of the applications. Now, other batteries which are under development are zinc air battery. I was given demonstration by one of the research laboratories of this. High theoretical energy density, high safety performance compared with the incumbent lithium batteries, and low cost materials for the electrodes allow lower overall manufacturing costs. There are drawbacks which our technology has not reached mass market so far. And of course, India has limited zinc research also. So that will be used only for smaller consumer electronics. Aluminum air is one combination which has attracted me maximum, because I find this only requires replacement of an energy aluminum plate and does not have any charging requirement and things like that. And it has got a high theoretical energy density, running into 8,000 and so on, and easily recyclable raw materials, because once you take that electrode, you can recycle and again get aluminum. Not susceptible to thermal runaway. India has abundant aluminum as far as this is concerned. Technology, I must say, it is in the R&D stage today. People have achieved up to about 3,000 whatever kind of a density today. Typically non-rechargeable, so battery replacement stations need to be built. Like we are giving the petrol and diesel today, I think we can supply the aluminum batteries. That could be one of the methods. Good applications for long-range EVs and unmanned air vehicles. Supercapacitors, all of you know, I don't have to explain, but the capacities of supercapacitors and a bundle of supercapacitors which can be used in various applications is what has to be done, and a management system for ensuring the correct supply at the high torque requirement time has to be ensured. So in the light of all this, that these kind of batteries are under development, you have zinc here, aluminum here, you have lithium ion, you have flow batteries, you have pumped storage systems, you have got compressed air storage systems and so on. It becomes imperative for us to look at chemistry agnostic standards for all of them. And that is what the government of India has looked at us. So for that, we first looked at what is the global picture as far as the test protocols for energy storage devices are concerned. US energy storage standard is backed by indigenous testing facilities and national laboratories. They have IEEE standards for different applications, stationary, electric storage, and battery energy storage systems integrated with electrical power systems. China have clear protocols for testing for electrochemical energy storage and lithium-ion batteries separately. The European Union Commission works in collaboration with US DOE for battery storage standards, so they practically follow the US data. As far as the international standards are concerned, like IEC and ISO, they develop standards for ISO focused on EVs and environmental management, and Underwriters Laboratory focuses with product-centric approach. So when we looked at it what BIS, our Indian standards, what they are doing. We have about 17 standards already, and 7 have been published on that. And they cover battery EVs, other batteries, lithium-ion and beyond, like grid scale electric energy storage systems, lithium-ion and beyond, and battery management systems. They are having different aspects have been covered, like safety and performance as the 2 major parameters as far as these are concerned. Different kinds of standards have been promulgated, and because there's so much of variability in these standards, the need has been felt for unifying and coming out a chemistry agnostic system. And hence we identified what are the major parameters as far as the chemistry agnostic standards are concerned. We said that in the specific parameters which are already included in the BIS standards are thermal safety, thermal temperature, mechanical vibration, electrical current variation, and chemicals. The standards of performance which they have highlighted are mostly on energy density, power density, cycle life, and charge rate. That is rate at which battery is discharged. What we feel that there should be common parameters required to be included, which will cover all kinds of storage devices, mainly like energy storage system. There are 2 blocks, that is storage block and the balance of the plant, the storage balance system. Then disconnection, disassembly, removal, and site remediation, because that's another very important parameter. For example, if you're talking of swapping of batteries, you need to give you the right kind of methods for disconnection and things like that. Then comes how do you integrate these batteries for grid? Now, as we mentioned, the peak demand and also the variability of frequency and load, all that has to be taken care of. So grid integration standards have to be taken care of. Then, of course, the power equipment that goes along with that, the capacity to cycle and recycle and disposal, how that will be disposed of tomorrow. Then response time and ramp rate, because that is another function which is very important for integration. Round trip efficiencies in terms of losses, and duration corresponding to the cycle life, calendar life, fixed operation and maintenance, what they are there, and site remediation, particularly when you talk of flow batteries. I think site remediation becomes a very important parameter. So we thought that unless you have this kind of a complete integrated picture as far as all the batteries and energy storage devices are concerned, we will not be in a position to make a proper call when it comes to public procurement and bringing systems for different applications. So we thought that there should be a committee, and we have started working together with the BIS today. So India required a universal standard for all types of energy storage. That is the way forward. Under universal standard, specific standard for type of storage and application needs to be notified. Till now, BIS has notified 17, and it takes almost 6 months to 2 years, which is a very long period, and hence we have to do something about it. That's why PMO felt that there should be a committee and that should come out with this kind of a standard. And we are now working along with academia, industry, and of course, Niti Aayog and different experts in this area. We would like to have ideas and inputs from all the experts who are present here to come out with something which is going to be more robust for our future applications. So I invite all of you to be part of this endeavor. Thank you very much for that.
Thank you, sir. I request our chief guest, Dr. V.K. Saraswat, to release abstract book to promote eco-friendliness. This time, we are releasing abstract e-book. Thank you, sir. Now I request Professor Pan to hand over the mementos to our chief guest, Dr. V.K. Saraswat. Thank you, sir. Now I request Professor Rastogi to offer the mementos to our guest of honor, Professor B.V.R. Chaudhary. Sir. I request Professor Yogesh Sharma to offer mementos to Director IIT Roorkee. Thank you, sir. Now I would like to invite Professor Soumitra Satpathy to extend vote of thanks to our delegates and participants. Please, sir.
Very good afternoon to all of you. Respected Chief Guest, Dr. V.K. Saraswat, Padma Bhushan, and member Niti Ayog. Our guest of honor, Dr. B.V.R. Chaudhary from NUS, our Director, Professor K.K. Pant, Chair, Professor Rastogi, co-chairs, all the deans, heads, faculties, distinguished speakers, participants, and my dear students. What a splendid inauguration it was. I like to thank all of you who have contributed to the success of this event in all different ways. First and foremost, I like to thank our Honorable Director, Professor K.K. Pant, for all his support from the very beginning of this event, without which it was not at all possible. Our Deputy Director, Dean Strick, Dean Infra, Dean International, Head Physics, all the faculty member of the Physics, all the faculty member of the newly established Center for Sustainable Energy. We thank all of them for their unwavering support and planning and executions of this event from the very beginning. Your guidance and encouragement has been invaluable, and without this, your support, it was not possible. A special note of thanks to Dr. V.K. Saraswat, our chief guest, for coming all the way instead of his not in the best of his health. And as I always tell, we don't see a better teacher than him, such a motivator and to see an ocean of knowledge. And as you can see from the talk today, we gained a lot of things from him always. And our guest of honor, Professor Chaudhary, I think we have a felicitation program for you also later tomorrow. And the students will be like to interact with you always. Head Physics, Professor Rastogi, for all his support and the events. We all thank you very much. And I also thank you all our delegates and speakers who came from all the way from the India and abroad to to participate in this event. And I'm sure that we'll all be enriched from your valuable research. And next 3-4 days there will be an extensive research discussions, presentations, networking, and we'll all benefit from that. And finally, our sincere thanks to our sponsors for supporting us in all different ways and financial support to this event. A special mention goes to our volunteers who are spending sleepless nights from the last 3 days for making each and everything goes to in completely glitchless event. As you can see today, it happened in such a mega scale. And finally, last but not the least, is the members of all the organizing team who are working from the last few months to make this event all success. So in conclusion, I wish to extend my gratitude to each and every person who was involved in this event. And I wish that next 3-4 days will be a very grand success for all of us. And we will all enjoy your stay at IIT Roorkee. And thank you very much. Thanks.
Thank you, sir. I request you all to rise for national anthem.
जनगणमन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड़ उत्कल गंगा विंध्य हिमाचल यमुना गंगा उच्चल जगति तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे आहे तव जय गाथा जन गण मंगल दायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
So now I think it is our inaugural function is closed. We will be going to all participants will be going to another venue for lunch, and next session will start I think 2:30 or yeah 2:30 at parallel session at lecture hall complex, Gargi blocks. So buses etc. is out.